Welcome to the Insightful Professor. Today's topic is simple data retrieval. In this video, we'll introduce the most basic form of the select statement, the data retrieval operation in the language called SQL. A data retrieval operation is often called a query because it presents a question to the database. For example, business questions that might be asked would be of the form, what are the rows in the employee table? What are the names and phone numbers of the employees who work in the HR department? We're going to look at how to express those questions in this language of SQL. The general structure or syntax of a select statement will be presented using simple examples in order to focus on the details of the statement structure. That is, we're going to try to grasp the syntax and master the syntax of the select statement, and later on we'll look at more complex things. So queries developed in this lecture will only involve a single table. In reality, a database typically consists of many tables with all the data necessary to answer any particular question spread across the database, stored in different tables. The issues associated with answering such complex questions will be addressed in a future video. So let's get started. We're going to be using the course table. We said there's a single table. This is the table. For the examples that we present in this video, we're going to have all of our queries focusing on this data table as our source. So what we see is there's one row for each course offered at the school. We note a couple things about some of these columns. C and O is the primary key. The purpose of the primary key is to uniquely identify a row in the table. If you examine the values in this particular table, as we're showing it here, you'll see that no two rows have the same exact value in the C and O column. So this primary key serves to uniquely identify a row. Similar in employee data, there might be something like your employee badge number. That would serve to distinguish you as an employee from other employees who might work in the organization. Now, observe the column called C department over on the right. There are duplicates. Okay, there are also duplicates in the credit column, and there are also duplicates in the lab fee column. So these columns would not qualify to serve the role of primary key because they lack the uniqueness property required of a primary key. Next, we focus on a column called C department. This is called a foreign key. This is how the relationship between one table and another table would be captured by using a foreign key. In this case, the course table is related to another table, which we'll examine later, called the department table. The relationship that's captured here is described by saying a department may sponsor many courses, but a course is sponsored by exactly one department. So the value in the foreign key would identify a single row in the department table that is responsible for the particular course that we're examining at that moment. So all the queries in this section are going to access only the course table. And you should be familiar with other tables in the database when you're working with any table. That's why we're giving you a little bit of a heads up on the fact that this table does not exist in isolation, but relates to another table. And that'll become more important when we get into the multi-table operations in later videos. So finally, we note that there are some columns in the table that can contain character data and some that can contain numeric data. For example, credit and lab fee are both numeric columns. The point is, by having a numeric data type, we can do different types of operations on that data than we could do with character strings, like what's present in C name and C description. Okay, that's the basic table that we're going to be working with. So kind of lock it into your mind, get an image there, and we'll move ahead. Now let's take a look at the basic structure of a select statement. Select and from as shown in this particular query, are what are called keywords. These words have a special meaning within the language of SQL. The keywords, by the way, are not case sensitive. I tend to write the SQL when I'm performing teaching or training sessions such that the keywords are in uppercase, they're easier to see, and perhaps a little bit more emphasis can be placed on them, but they are not case sensitive. The system does not object to you entering these values in lowercase. We'll also see that the table names and column names are said to be user-defined. Here we don't really see any columns, but we'll see some in just a moment. The name of the table is course, and notice that that table name, course, appears within the from clause. Now, in this particular query, we're selecting asterisk. Asterisk is an abbreviation for all columns. Basically, what we're saying is the table might contain 2 columns, 4 columns, 1,000 columns. Return all of those column values to me. Now, when they're returned in a particular left to right order, which is determined when the table was created. So there is a default left to right display sequence for the columns when you say select asterisk. In practice, you really don't say select asterisk all that often, because if you consider all of the data elements or data items which might be used to describe you as a student or as an employee or as a player on some team, whatever the table or database might pertain to, you'll recognize that there are going to be a lot of columns that the values are not going to be relevant to answering a particular question. So we're going to look at how to select a subset of columns, but in practice we're saying you could do select asterisk, but very unlikely you're going to do it on a regular basis and with very large tables. So let's take a look at how this works. We'll go into the database and fire this up. I'm already connected to the database, and in these examples I'll be using Oracle. However, keep in mind that SQL is a standard language. I'm going to be writing queries, running the queries, and for the most part, the queries that I enter will behave exactly the same if we were using Oracle, DB2, SQL Server, MySQL. It's fairly generic. When we encounter a form of a query that I'm presenting that might behave a little differently in one system versus another, I'll bring that point to your attention. But let's take a look at this query. The query said select asterisk, and then I hit enter from course. We don't have to put it all on one line, but I'm going to do that here to be consistent with the example that we started with. Now, to signal to this front end tool, which Oracle calls SQL Plus, that this is the end of the input stream, you append a semicolon. A semicolon technically is not part of the syntax of SQL. It is used to signal to the front end tool through which I'm entering the query that this is the end of the input stream, package it up, and ship it over to the server for execution. So now I'm going to hit enter and watch what happens. It says I'm not connected. Great. So how do I connect? Well, I connect to the database by saying let's connect student Oracle. Now we'll take the query that we just looked at and execute it. So I'm going to copy that here and fire it up. There's the output of the query. That's what we want to see. Now, this is exactly what we looked at in our overview of the course table. All 14 rows are returned. Now, you're going to see the data presented in a slightly different way depending upon which front-end tool you're using and hence which database you might be talking to. But the content of the database table itself is going to be rendered essentially the same. Down here we have feedback information that Oracle puts over here in the lower left corner. This is how many rows were selected. If we were executing this query against the SQL Server database using what's called SQL Server Management Studio, the feedback information would be shown in a different location, but we would still get some acknowledgement that there are 14 rows. It would be shown over, say, in the lower right corner. But the point is, we got all of the columns, and in the absence of what's called a where clause, we got all of the rows. This is the entire table. A grand total of 14 rows. Not very big by real-world standards, but big enough to serve our purposes to be able to use a lot of the different aspects of SQL. Now, the rows presented here don't necessarily come back in any particular order. In this case, they do appear to have some order. All of the CIS department rows, all of the philosophy department rows, then all of the theology department rows. So it appears as though there's some order imposed. Don't count on that happening when you run a query as we've just done here. What happens is, unless you explicitly tell the system to impose an order on the rows by including what's called an order by clause, the rows will come back in any old order. The order is dictated or reflected by the way that this software component called the query optimizer decides to retrieve the data. Remember that SQL is said to be a non-procedural language. And what this means is we have described what we want, but nowhere within this little select statement did we say how to get the data. We didn't say do a sort. We didn't say use an index. We're not telling it how to produce the result. We're simply describing what the result is. That's the notion of non-procedural. It's the query optimizer that takes your what request and determines how to render the result, how to obtain the data and subsequently render the result. So this one, just coincidentally, the rows for this particular database happen to be stored in a particular order, and that's how they were returned to us. But don't count on that happening. Okay, let's continue on. To make the query a little bit more exciting, we don't want to retrieve all of the rows. We want to retrieve only some of the rows. Our table has only 14 rows. In practice, you might see real-world database tables having thousands, hundreds of thousands, millions, hundreds of millions, maybe even billions of rows. So we want to be very specific and retrieve only the rows that are relevant to answering our particular question. If I have 14 rows, the user can look at that output and kind of visually examine and say, yeah, I got what I wanted. But if I have 1 million rows, the user is not going to visually scan all 1 million rows to determine if the rows returned do indeed answer the question that was presented. So in order to identify the rows that are relevant to answering the question, and only those rows which should be returned by the query, we use something called a where clause. The where clause is going to be introduced to our select statement, and the purpose of this is to identify a search condition or a retrieval condition which must be satisfied by a row in order for the row to be passed on for further processing, in our case, in order for that row to be displayed in the output and rendered on the screen. So every row that satisfies the where clause condition will be processed further, will appear in our results set. We can think of the where clause condition as being kind of a true-false condition. We more formally would refer to it as what's called a predicate. The idea is we're expressing a statement in this condition. That statement is evaluated, and it will evaluate as either true or false for each row, and for those rows for which the predicate or the condition evaluates to true, those rows get passed on, and we'll see them in the output. If the predicate or the condition evaluates to false, that is, if it's not true for a particular row, that's the end of the row. We don't see it in the output. So let's take a step further with a query that includes a where clause. In this query, we've indicated what the query is going to do. It has a where clause that says lab fee is equal to 0. Think of that again as a condition or a predicate, a statement we can make. We could say lab fee equal to 0 in this row. Now, as you look at the rows in the table, for some rows, lab fee equal to 0 will be a true statement about the row. But for other rows, lab fee equal to 0 will not be true. It'll be false. Maybe the lab fee is 100 in some row, or the lab fee is 50 in some row. For those two rows, lab fee equal to 0 is not a true statement descriptive of that row. Those rows will not be included in the result. So this particular query returns all the rows that have a lab fee value equal to 0. So the conditional operator we've used here is equality. Now, The value that we're using is 0. Notice it's not enclosed in any kind of delimiters like quotation marks or apostrophes. That's because the CLAB-V column is a numeric column. So when we introduce literal values that are numeric, they are not enclosed within any kind of quotation mark or apostrophes. This particular query just has a simple predicate, a simple condition, but complex predicates can also be specified. And again, that will come up in one of the next videos that we discuss. Other comparison operators can also be used, and we'll discuss those in a moment. But let's go to the database and fire this guy up. So what we want to do is say select asterisk from course where lab fee is equal to 0. Put the semicolon to signal the end. Now remember, the previous query showed the entire course table. So before we execute this, let's try to figure out which rows satisfy the condition of lab fee being equal to 0. Well, if you take a look at the first row, its lab fee is 100. Lab fee equal to 0 is not a true statement about that row. Likewise, the next row with 50, it's not true. But notice this next row here, course C33, C lab V is equal to 0, that row will appear in the result. Likewise, the row that follows that here, C44. So those two rows satisfy the condition. Scrolling down further, we see that this row here, P44, solipsism, that has a lab V of 0, and hedonism, T33. So let's fire up the query and see if we do indeed get those 4 rows and only those 4 rows. Sure enough, that's exactly what we got. Boy, this is exciting stuff, isn't it? It works the way it's supposed to. Not that difficult. Okay, so we're looking at the predicate here saying lab v is equal to 0. That gets evaluated on a row-by-row basis, and for only these 4 rows out of all 14 rows in this table did the predicate evaluate to true. Those are the rows that are returned. Okay. The other comparison operators that we could use, where we said lab v is equal to 0, we're not limited to equality as a comparison operator, but we could use things like less than. And notice it's this simple kind of arithmetic less than operator. Greater than. Then notice less than or equal to is a combination of the less than symbol immediately followed by the equal symbol. Has to be in that order, less than, equal, 2 consecutive characters that you type in as the keyboard, that represents a less than or equal to condition. Furthermore, we can do greater than or equal, and not equal is kind of interesting because we have a couple different ways to do that. We could say less than greater than, that symbolizes a not equal condition, and we could also say exclamation mark equal. So let's go back and try these real quick. So suppose we wanted all of the courses whose lab fee was not equal to 0. We would say select asterisk from course where lab fee, and we could use less than, greater than, that would give us not equal. And notice this time we get 10 rows. Previously we had 4, and we noted on our first query that the table contained 14. So we excluded these 4 because the predicate did not evaluate to true for those rows, but did evaluate to true for the other 10. So this seems to be working just as advertised. Okay, we also could go ahead and say select asterisk from course where the lab fee is not equal by using exclamation mark equal and put the 0, fire that up, and we get the same 10 rows. Is there a difference between them? No. They mean the same thing. Functionally, there's no difference. There's no meaning difference, so no semantic difference. The only thing that might happen is if you're working with some programming languages where exclamation mark might be used to precede an equal operator, then you're more inclined to write it this way. It's more natural for you if you're comfortable and proficient in that programming language. So they support that within the ANSI SQL standard. In some languages, well, maybe you'd write the not equal in this way, so SQL supports that. And it also has to do perhaps with keyboards that have been made available in terms of which keys are available. So anyway, you've got a choice as to how you can say not equal. Okay, that's the basic idea. And we've seen a couple of different relational operators now. And again, go ahead and try these out on your own to see how they work. Now, the next example is a little bit of a different twist. In this case, the predicate is testing not a numeric column, but a character column. C department contains the name of the column for the department ID that is found as the primary key in the department table. So we're going to have strings, as we saw in our output in our sample queries, of CIS, which is character, not numeric, or PHIL, character, not numeric. So therefore, when we're providing a character string, here's where we want to give a little bit of attention. The question that is being asked here, by the way, is which courses are sponsored by the philosophy department. Remember that C department is a foreign key. What we're doing is saying which rows in the course table have a foreign key value that identifies the department called philosophy in the department table. So you can see that the English, which courses are sponsored by the philosophy department, doesn't exactly align with the way you might formulate the query in SQL. But it's just like translating from one natural language to another, translating from English to German or English to Chinese. There are going to be some changes that may be made structurally in how the sentence is expressed. Well, it's similar here. But the gist of what's going on is hopefully going to be conveyed to the database, but you have to think about it from the business perspective. Now, let's take a closer look at this query, because this is an important one where we want to give close attention to the behavior of this in different databases. This is one that you want to pay close attention to because it doesn't work the same way in all database systems, even though it's standard SQL. So what I'm going to do is I'm going to go ahead and write the query, say select asterisk from course where C department, the sponsoring department, is equal to PHIL, and fire that up. And notice I get only the rows that say philosophy in the C department column. I don't see any theology rows. I don't see any computer science rows, just philosophy. So it worked. Now here's the difference. Select, from, and where are keywords. They are not case sensitive. Let me show you that by changing, and we'll say select asterisk from, and the name of the table, course, is not case sensitive. And we'll say where, and we'll say C department. But I'm going to put within quotes the character literal, the character string, as uppercase. I fire this up, and I get the data. So notice the way I wrote the query the first time, keywords, table name, column name, they were uppercase. Here I write them in lowercase, and I get the same rows back. The same rows are returned to me. So the keywords and names of tables and columns, those are not case sensitive. But the quoted string here, the values, that's what we have to give attention to. If I take the query that I just wrote and say select asterisk from course where C department is equal to, and I modify the quoted string and put it as lowercase, PHIL in lowercase, Oracle doesn't find it. See, what's stored in the Oracle database is exactly what's displayed on the screen, uppercase. Likewise, if I were to formulate this query with DB2 and the data was stored as I'm showing it here in Oracle, the same way in DB2, stored in uppercase, then DB2 also would not find rows that say philosophy, because this is different. Lowercase values using ASCII or Ipsidic or Unicode, whatever the representation is, lowercase characters are represented in a different way, a different code value than what you have for uppercase. So therefore, this quoted string of lowercase letters doesn't match any row in the database, they don't come back. Here's the exception. If you look at SQL Server databases are generally configured to be case insensitive. So if you wrote the query as I just did here, and the values had actually been stored in your SQL Server database in uppercase, this query, where the predicate uses a lowercase character string would actually return all of the rows, even though you entered lowercase, but it retrieved uppercase because that's what was stored. Very different behavior. So that's something you want to be very clear on. In terms of standard SQL, there can be subtle differences between various products. So that's an important point to be aware of if you're working with SQL Server and also working with Oracle. I've had experiences where I'm training IT professionals where they are very experienced with SQL Server, and then I start to introduce them to Oracle, and I have them do various exercises. I say, okay, run this query. That's the first step. And they type it in all in lowercase because it's a habit that they formed while working with SQL Server. What happens is no rows are returned, and they're surprised. Well, I say this is the problem. You've got to enter it in uppercase because that's how the values have been stored in this particular database that you're working with. So the stored values are going to be case sensitive in DB2 and in Oracle, but not necessarily with SQL Server. Okay, something pretty important to be aware of. Okay, let's go back, take a look at what else we have to say here. Also, when comparing character data, we can use any of the relational operators. We used equal and we found our exact match, but we could also use greater than or less than. We can use some kind of inequality. Now that's kind of interesting because if you think about it, when would you ever do such a thing? Well, have you ever looked for a word in a dictionary? You've actually done compares of this sort. As you're going through the dictionary, all of the words are arranged in alphabetical order. So what we're asking here is identify those courses, those rows in the course table, where the name of the course, say alphabetically or in dictionary order, follows hedonism. We don't really think of one name as being greater than another name, but if you recognize that when you're dealing with character data, what you're seeing is that greater than and less than are referring to what would be called lexicographic order or dictionary order, putting the words in order according to the spelling. And that's really what we're looking at here. Okay, so this is not saying one name is greater than another, but identify all those courses that have a course name that alphabetically follows hedonism. Let's go and give this a try just to demonstrate it. Select asterisk from course where C name is greater than hedonism. And we fire that up and pay attention to the C name values here. If you were to look in a dictionary and you entered the dictionary right at the page where it said hedonism, what course names would come after that? You've got Intro to CS because alphabetically this begins with an I, so that comes after hedonism. Relational database, rationalism begin with R. Solipsism, scholasticism begin with S. Notice courses that did not appear. If we look back at the top of the display here, we didn't get empiricism or existentialism because alphabetically those appear before hedonism. Therefore, they are considered, when we do our relational compare, as being less than the character string hedonism. So they weren't returned. That's the idea of greater than or less than. So here's another little thing to be aware of. We're translating a business request that says identify all those courses that have a course name which alphabetically follows hedonism. Well, we have to translate that in SQL to being a greater than type of compare. So again, you have to recognize how you express that concept in a language such as SQL. The way character strings are actually compared is it's done on a character by character basis. We compare the first character in, say, in hedonism, the H, to the first character in the C name column of some row. If they're the same, then we proceed to compare the second. If the second is the same, we proceed to compare the third. We continue until we've exhausted all of the characters in our two strings being compared. or until we encounter an inequality. So say, for example, I had HA something or other. Well, the H would compare equal to hedonism, but the A would be less than, so it wouldn't satisfy the condition. The predicate would evaluate to false. We wouldn't see that particular course. Okay, so far we've displayed all of the columns and only some of the rows. Now what we're going to do is have some control over which columns are going to be present in the result. And we do this by modifying our select clause. We remove the asterisk because we no longer wish to see all of the columns, but we identify only those columns of direct interest to us. So in this particular example, I've specified I would like to see the CNO column, followed by the CNAME column, followed by the C department column. And this is accomplished by introducing the name CNO, then following that immediately with a comma, then putting the next column that I want to appear immediately to the right of CNO. In this case, I've specified CNAME. And if there are more columns, comma, and then the column name, comma, and then the column name, and so forth. And I can list the columns in the left to right display sequence that I want them presented in the output. I'm not obligated to display them in any particular order based on how the columns are stored in the table. This is a concept referred to in database as data independence. Completely independent of how things are physically stored, I can formulate my query such that, oh, I want to see the CNAME column before the CNO column, even though that's not how they're stored, just by changing the order. So let's take a look at that in action. So let's say we say CNO, CNAME, CLab fee from course. Now there's no where clause, so remember we're going to get all of the rows. We get 14 rows. The absence of a where clause means you get the entire table. Every row participates in the process. But notice I specified give me CNO, then CNAME, then CLab fee. We can change the order by saying, let's say CNAME, CNO, and then CLab fee. I list the columns in any order that is relevant for me, for my question, and sure enough, I get CNAME first, even though physically in the database it might be stored before CNO. This is a concept, again, called data independence. Really a neat feature. So we get to get the data back to us in any way that makes sense, any way that's useful for us in achieving our particular goal in answering some business questions. Really pretty powerful, really pretty impressive. Let's move ahead. And I think we pretty much covered everything here. Let's go to the next one. Displaying a subset of rows and columns. There should have been a drum roll to introduce this. This is exciting because we could see the entire table. We could see some of the rows. We could see some of the columns. And finally, we can see a query that is really, really practical. A subset of columns and a subset of rows in the same query. Ta-da! This is really pretty useful. All we do is we simply select the columns of interest to us in the left to right order that we wish to see them, and we include a where clause that introduces the predicate or the search condition that must be satisfied. We will get only the rows satisfied by the condition expressed in the where clause, and we will see only these columns. Now, here's where it gets really neat. Notice I'm selecting course number, department, and lab fee. Let's go ahead and do this. Select course number, course department, course lab fee. And again, notice the order is different than the order in which the columns are physically stored. Then I inject the predicate that says the lab fee must be less than 100. I fire that up, and now I get these three columns, but only the rows where this condition is true. Notice all of the lab fees that you see in the result are indeed less than 100. Notice we didn't get the course that had a lab fee of 200, the one who had 150, even the one that had 100, because we chose a condition or a relational operator of less than. So that's what we got back. Here's the real exciting part. Brace yourselves. This is exciting. It gets even more exciting. I can say select course number, course department, course lab fee from course. But I say, well, wait. Maybe I don't want to see the lab fee. Let's back up here. Let's select course number, course department. I don't actually want to see the lab fee, but I want to use it to determine which rows come back. So I'm going to say select these these two columns from course where, and notice that I'm using the lab fee column to formulate my predicate or search condition to determine which rows come back. But I'm not obligated to take the column that is used for testing purposes. I'm not obligated to display that. Watch this. Now that is really exciting. Scroll back just a little bit. We got the same 7 rows, except we did not include the lab fee in the output. So you can use a column to express some criteria that has to be satisfied for a row to be retrieved, but you don't have to display the value in that column. That might be particularly useful if the column actually might contain sensitive information, where I'm interested in identifying the rows that meet a certain condition, where maybe this is the salary of an employee is less than or greater than some value. We don't actually have to display the salary in the output. We can suppress that, as we did in this case. We're using it for testing purposes to determine which rows are returned, but we don't have to show it in the output. That is really exciting. Okay, just take a deep breath, calm down, and we'll look at a little bit more. Okay, this is the example I was just talking about, so you can review what I have here on the slide. I'll leave it up for just a moment, but this is exactly what I was illustrating. This is really such a powerful feature. Okay, in the next slide, I summarize what we've talked about thus far. Up to this point, we've talked about selecting a subset of columns, and here's effectively how that's accomplished. One column, comma, another column, comma, another column, comma, and so on, up to as many columns as we wish to have displayed in the output. Then we say, where are these columns coming from? They will be coming from rows in a particular table. So we specify in the from clause the name of the table. And finally, if we wish to return those columns from only some of the rows, then we express a condition or a predicate in the where clause. This is the important part about this syntax. It's not complicated, but what we have to recognize is select appears first, then from, and then where. There is a strict order in which the clause must be coded. It's just like formulating sentences in whatever your natural language is. You have a certain grammar, a certain syntax that you have to abide by as you formulate or express sentences. It's the same thing here. The rules here for expressing a query say select to identify the columns, from to identify the table from which you'll get those columns, and where to identify which rows will provide their columns as requested. That's the syntax. So remember that. Now, it's possible that duplicate values could appear in a column. We saw that when we were looking at C department in our quick overview of the course table. But CNO has no duplicates. So sometimes when you select a subset of columns, if you select certain columns where there's no guaranteed uniqueness, that is, you don't specify the primary key, for example, it is possible that duplicate rows can appear in the result. Take a look at how this goes on. We will say select C department from course. Remember, there are 14 rows. I've omitted the where clause. I get 14 rows. So each row in this case has only a single column value, and that column value is in the C department column. But notice, there's no way to tell these 6 rows apart. They all look identical. They all say CIS in that single column. Nor can I distinguish any of these 4 rows or any of these last 4 rows. These are considered duplicate rows, and we don't want to see that. For example, remember C department is identifying the department that is responsible for or sponsors the course. So the question that is being asked here is, which academic departments currently sponsor courses? Well, you can argue that this does answer the question, but if you were asked the question, which departments sponsor courses, and someone came back and said, CIS sponsors courses, CIS sponsors courses, CIS sponsors courses, CIS sponsors courses, you're probably going to get annoyed by that answer. You only need to be informed that CIS sponsors courses one time. You only need to be informed that philosophy sponsors courses one time, regardless of how many courses they sponsored. See, that's not the question we asked. We didn't ask how many, we asked which departments sponsor courses. So we want to get a way that we can see CIS one time, even though it may appear many times naturally in the result, or same for philosophy and theology. How do we do that? Well, there's a special keyword that's part of SQL. We note that the duplicates here were preserved by the system. The system does not automatically remove duplicates. So the way we have to do this is by making our request explicit to say, hey, I don't want duplicate rows, by using a special keyword called distinct. We inject the distinct keyword immediately after select and immediately before our column list, and that will remove the duplicates. Give it a try. So we take our original query up here, and we're going to modify it. Select distinct C department from course. Just adding that one word, and watch what happens. We go from 14 rows to 3 rows. There are no duplicates. Duplicates are removed by using the distinct keyword. Pretty neat stuff. Okay. Now, there's a reason here. If you go back historically, it's kind of nice to know why we do things a certain way. Why doesn't the system remove the duplicates for us? This relational database is based upon mathematical relations or sets which don't allow duplicates. So if a table is in a sense a representation of a set, why are duplicates preserved in the output here? That seems inconsistent. Well, it was a practical or pragmatic issue. Way back when they were working on relational database, trying to get it to work, it was back in the 1970s. That's a long time ago. Back in the 1970s is when they were developing prototypes to get this stuff to work, to apply the theory and come up with something practical. Well, at that time, duplicate removal was very expensive. We weren't talking about computers with gigabytes of main memory. Some of these computers didn't even have megabytes. They were talking about kilobytes of main memory, and the processor speeds were nothing like what you see today. So it was actually very expensive to remove duplicates. So the people who were developing SQL said, well, because of that cost, we'll let the duplicates stay there, and if a user really wants to get rid of them, then they can use this distinct keyword and say get rid of the duplicates. But recognize there was a serious expense associated with it. Nowadays, we don't think of that as being such a serious expense because of the power of the machines that we're working with. But again, it does cost us a little bit, potentially, to remove duplicates, and you might want to keep that in mind. Okay, now let's take a look at another query. Here's a query, still titled Removing Duplicates from the Display, but look at this. We're selecting a subset of rows rather than all the rows, so that decreases the likelihood that we would have duplicates. And furthermore, we're selecting multiple columns. Well, it turns out you can still get duplicates. Let's select Department and Credit where the lab fee is less than 100. Fire it up, and we get 7 rows. Observe that the first 3 rows are identical. Even though they have 2 columns, you can't tell those 3 rows apart. C department is CIS in each of those 3 rows. Credit is 3. They're identical. Furthermore, the 2 theology rows are identical. So the point is, even if you select multiple columns, there is still a possibility of duplicate rows appearing in your result, even if you have a where clause to produce or access a subset of rows. As long as you fail to select the primary key or any column whose value is guaranteed to be unique within a table, there is the possibility of duplicate rows appearing in the result. So how do we get rid of it? This is pretty instructive. We would say select, and what did I say we would do before? Insert the distinct keyword immediately after select and before the column list. So we do this. And you might say, well, you're using distinct only once, but there are 2 columns there. Don't you need to use it for each column? Well, watch what happens. Turns out that distinct applies to the entire row that's being produced. And in this case, that row consists of a combination of department and credit. So notice where we had 3 rows that say CIS3 in the initial result, we now have only 1. And where we had 2 rows that say theology and 3 in the original result, we now have only 1. Pretty exciting. The 2 philosophy rows are both in the output of this query as well. Why? Because if you compare the combination of all of the columns that are part of the rows in your result set, these 2 rows are distinguishable from one another. They are not exact duplicates. They each have a different credit value. Even though distinct was coded immediately before the C department column, it did not affect just that column. It affected the entire row that was constructed. And that's how these 2 rows were interpreted as being distinct from one another. So that's the idea of duplicate removal. Now, a common mistake that I've seen people do in training classes is they feel this urgent need to say distinct C department, distinct credit, and they want to use it for both columns. Well, let's see what happens when you try to present this to the system. The system doesn't like it. And this doesn't matter whether you're using Oracle or DB2 or SQL Server. None of the systems allow you to use distinct more than once within a query. It comes up and says you've got a missing expression. That's because it's totally confused. It says, I don't know what this is. You've already got a distinct here. What is this? It doesn't make any sense to me. Now, the error messages that you get with the front-end tools for SQL Server or DB2 or MySQL, the error messages might be more meaningful or informative to you, but the point is the systems are all going to reject queries of this sort. So we violated the syntax. And the details of the error message might vary between these systems. So this reminds me of an old ad many, many years ago. They used to have this kind of a little cream that you could put into your hair to get your hair to look just right. Men would use this, and the slogan that they had was, a little dab will do you. And that's the idea of what we have here. A little distinct goes a long way. You only need distinct one time. Okay, moving ahead. Here's the example that we were talking about with the 2 columns, causing duplicates. And then the distinct is how we remove it. And we've just talked about that and demonstrated that. Now, another thing to be aware of. This is something that you might find useful, particularly when you're dealing with multiple tables. Okay, a client that I had, what they've done is the database column, sometimes the names are kind of cryptic, not that meaningful. Like, look at the example I have here. They've got C description, but it's not spelled out, so that column heading may not be that meaningful. Well, a client that I have, something similar with them. They have column names which don't really hit the point of what the data actually means in that column. It doesn't really express the business purpose. So if you simply retrieve a column by using its column name, you're going to see that that becomes the column heading that's presented in your output, and that may not be meaningful to users. So you have the ability to change the display here of that column heading. So instead of using the column name of the table by default as the column heading, you can replace it by using this as keyword. This is standard SQL. So let's give this a try. Whoops, come on. We're going to say select course number, course description from the course table. And I fire that up, and notice that the column heading of C description is what appeared in the output. Not necessarily meaningful. So we'll modify that and say select course number, course description as, and we give it a new name. Fire that up, and notice even though the values are coming from the database column called CDESCP, presented, the column heading shown is this word description. We have renamed the column for display purposes. We have not changed the name of the column in the actual database table. It's still called CDESCP, but for display purposes in this query and this query only, we have altered the column heading. So that's what we've accomplished here. Okay, so that's actually an important thing to note. Now, let's take this a step further. I'm going to take this query where I said, let's select the course number and the description, and I'm renaming, and I'm going to select this from course, but I'm going to put a condition in here where I'm going to say where the C department, which is a character column, is equal to, say, CIS. Okay? Now, this is what I want to bring to your attention. Notice that when you use the as, you're saying display this column as this name. The name that you're using when you rename a column is contained within quotation marks, or what a lot of IT people tend to call double quotes. So quotation marks or double quotes. Values that you're using, such as in a where clause where you're injecting a character literal, are enclosed within apostrophes, or what IT folks tend to call single quotes. Apostrophes or single quotes enclose values, quotation marks or double quotes enclose names. If you remember that, you shouldn't have any problem in formulating your queries. Be consistent and you won't have difficulty. If you try to put your query such that you're going to say, well, I like double quotes or I like quotation marks, so I'm going to go ahead and put my CIS value also in double quotes, what's going to happen is the system is not going to appreciate your attempt to use double quotes down there or quotation marks. It comes back and says, oh, you got an invalid identifier. What happens is it tends to think that that is a name. Just like up here, this is a name. It says, oh, C department is the name of a column, and you're comparing that to, oh, this thing is in quotation marks. This must be another name somewhere in this table. So you're saying where this name of C department is equal to this name over here, and it doesn't make any sense. The system gets confused, and you get an error. So when you're providing values as character literals, use apostrophes or single quotes. When you're renaming, use quotation marks or double quotes. Just remember that and you won't have problems. Now, this one seems a bit odd, but this is kind of an interesting query to present. We could also select within a query what would be considered a constant value. This is a technique that might be used very often by people who are trying to generate test data or generate queries that are going to be using some data from within a database. It's a pretty neat technique. We may discuss practical applications of this down the road, but let me give you the idea of how this works. Select course number, course name, and then expensive. Now, expensive is not a name because it's not in quotation marks. It is a value because it's in single quotes or apostrophes, just like that CIS we did a moment ago. So when I do this and select this from the course table and put the condition such that the lab fee must be greater than 100, say that's our criteria to determine that this is an expensive course, fire it up, and notice the value, which is this character string, expensive, appears in every single row. Okay, don't worry about the practicality of this at this point. We'll show other examples later on why this can be useful, but just be aware of what's happening there. What I want to show you at this point is that this value here of expensive was not retrieved from a database table. C66 was stored in the course table and it was retrieved and displayed. Relational database was stored in a course table and it was retrieved and displayed. And the same is true for these other course number and course name values. But this character string expensive was not retrieved from a database table. In a sense, this is a derived value. This was made up within the query. It was not something retrieved from the database. Here's the rule that I want to get across to you. Notice that the column heading looks a bit odd. What Oracle did with this particular tool was it used either the entire expression, or in this case, a portion of the expression that was used to derive the value as the column heading. Clearly, this is not that meaningful to a user of the database. So this is where we take it a step further and show you something practical in terms of renaming. But again, keep in mind the distinction between single quotes identifying values and then double quotes identifying names. So now what we see is we have a meaningful or descriptive column heading where we have a column of derived values. This concept is extremely important to grasp because later on in one of the future videos when we talk about built-in functions, we'll talk about scalar functions and we'll talk about aggregate functions. We will be deriving values from what's stored in the database to produce something different than what was actually stored in the database in the result of our query. These values are derived, hence they will not automatically be given meaningful or descriptive names. We will want to use this technique of renaming the column for presentation purposes. So it does have practical application, as we'll see down the road. Okay, one other thing to be aware of is that when you're dealing with columns in a table, the column names must be unique within the table. That is, you cannot have two columns called C lab fee in the course table. Because if you said select C lab fee from course, that would be an ambiguous reference. The system wouldn't know what to do. So you cannot have duplicate names of columns within the same table. However, you are not prohibited from having two columns that have the same name, but they reside in different tables. When we talk about multi-table operations, we'll see many instances where that may occur. So when you select from one table and join it with another table, and the two tables share a common column name, you're going to have to distinguish between which one of the column names, the one from table 1 or the one from table 2, you want to actually render in the result. And to do that, we qualify the names of the columns. So here what we're doing is we're putting the table name, in this case course, immediately preceding the name of the column and using a dot. So this is cleverly called the dot operator. So table name dot column name, course.c department, course.credit, course.c lab fee. And we're qualifying the name of the column with the name of the table. It's not necessary when you're dealing with only one table, but it's a good technique to be aware of, even if you are working with one table. Because if you're working with a tool that generates SQL queries, some kind of a report type of tool where you tell it what you want and it writes the SQL, and then you examine the SQL that was generated by the tool, that tool may very well use this query technique of qualifying the column with the name of the table, even though when you're accessing a single table, it's unnecessary. But later on, we'll find this is almost a necessity when we're dealing with multiple tables. Okay, and then what we want to look at is controlling the order of presentation. When we run queries against the table, like when we ran the query and said, give me all of the rows, all of the columns, show me the entire table, select asterisk from course. Remember I said we kind of were fortunate that the rows were displayed in some order, but don't rely on that. So how can we be assured that the rows will always be displayed in a particular order? The secret is to use an order by clause. So the order by clause identifies one or more columns that will be part of the query data that you're working with, and it specifies how to impose an order on the columns. Let's take a look at this guy here. This is going to select all of the columns from the course table. No where clause, so it will also select all of the rows, but we will impose an order on the result. So select asterisk from course, order by this column named C lab fee. And when we do that, observe the result. In the C lab fee column, which is a numeric data type, we see we have sorted the data from small to large. This is what is referred to as ascending sequence. The default behavior when you apply an order by is to control the ordering in ascending sequence. We can make this explicit if we wish, and some people choose to do this to add clarity to their query. We could say order by lab fee, then a space, and then ASC is the keyword for ascending, and we get the ascending sequence. So we can say order the rows by this numeric column in ascending sequence. So naturally, you're probably asking, well, if you can do it in ascending, can you also do it in descending sequence? And that's an excellent question. I'm glad you asked that. Let me show you how to do it. We say select asterisk from course, and we'll say order by C lab fee, DESC, and now observe that we go from largest to smallest. This is the descending sequence. So this is great with numeric data. It will also work with date-time data, because dates, if you talk about when does the 4th of July occur, well, that occurs before the 5th of July or before the 1st of August and so forth. So the point is that dates have an order that are imposed on them, not just months and days, but also calendar years. And we can apply order by when dealing with date time or chronological data. That's pretty neat. Furthermore, we can apply data ordering using the order by clause when working with character data. That should not come as a surprise to you, because when we talked about our predicate where we said CNAME is greater than hedonism, that was basically imposing some kind of order or relying on order of character data. So we can actually go ahead and say, let's select asterisk from course, order by, and we can do something like order by CNAME, and we can do that in reverse dictionary order. That's what descending would be. We could also do it in ascending order. So this is like starting at the back of the dictionary and working our way towards the front. Likewise, we could omit the DESC and it would default to ascending, or we could make it explicit and put ASC. Now, as excited as you might be about this, just calm down, because I'm going to show you something even more exciting. We could say, let's select from course, order by, and let's get all the rows for the same department together. All of the CIS, followed by all of the philosophy, followed by all of the theology. So we accomplish that by doing ascending. But then we say, within each department, we want to order the rows by lab fee, and perhaps here we want to do it in descending order. And we fire that up, and wow, here we go. Here are all of the CIS rows. They all precede the philosophy rows. They all precede the theology rows. That's because of this first part of the order by. That's the primary ordering column. The secondary ordering column in this example is lab fee, a numeric column. So observe that as you look within the CIS courses, that's where the secondary ordering kicks in. We go from largest to smallest. Similarly with philosophy, and likewise with theology. We can go further. We can have order by this column, that column, a third column, a fourth column, a fifth column, pretty much as many columns as we need to get the rows or get the data in the precise order that we need to operate upon that data or to examine that data for further business purposes. But this is how we would do it. The same way in the select clause, you list multiple columns that are comma separated. You list in the order by the columns, and keep in mind the order in which you list them. C department is listed first, so that's primary. After that is C lab fee, so that's secondary. If we then went within credit as the third column, that would be our tertiary done at that level because it's first, second, third in the left to right order in the order by clause. But notice we separate these columns with commas. The same idea as how we separated the columns within the select list for those columns that were to be retrieved for us. Now, just show you one more variation on this. Select asterisk from course, and what we're going to do is something like where credit is equal to 3, then we're going to throw in an order by. And as we do this query, what we're noting is we only have 12 rows because only 12 rows satisfied this condition. But let's look at the syntax. Select, which columns do you want? From, where are you going to get the columns? Which table? Where, which rows do you want? And the last clause is order by. Order by is always going to come at the end. Again, remember the sequence of the columns as part of the syntax of the language. Select, then from, then where, and finally order by. Okay, we've talked about ascending, so the default sequence is ascending. ASC can be put in there to make it explicit, not required, but you may very well find people putting that in there for clarity. Here's a similar example to what we looked at a moment ago. You could have a where clause where the where clause is evaluated first, then you have the order by after that to order just the rows that you selected, and again, this is illustrating descending. We also can select multiple columns as we demonstrated, where we have what might be called primary and secondary sort fields, or major and minor fields. And again, we walked through an example already, so you can go ahead and try this slight variation on your own, but it's pretty much the one that we ran. Excuse me. Now, to summarize what we've talked about here, the select statement is the data retrieval operation in SQL. The from clause identifies the table from which data will be retrieved. That follows the select clause. The select clause identifies the columns to appear in the result and determines what the left to right display sequence will be in your output or in your result. To retrieve a subset of rows, we use the where clause, specifying a search condition or predicate. That condition then is evaluated on a row-by-row basis, and for each row for which it evaluates to true, those rows will be returned in the output. For the rows where it does not evaluate to true, those rows are discarded. They do not appear in the result. We also talked about column renaming. And again, any of the things that you do with select, like renaming or excluding rows, I talk about discarding them here with the where clause, keep in mind that select is a read operation or a retrieval operation. It does not alter the content of the database. So don't be afraid to use this. And then finally, the order by clause is used to control the order of rows as they are included or presented in the result set. And that pretty much does it for our quick intro, well, not so quick, but our intro into operating or retrieving data from a single table. We'll follow this up with another video where we'll be looking at retrieving data from a single table using complex where clause conditions or complex predicates. That will be the next one that we'll put out. So if you found this video useful, let us know in the comments section and consider subscribing to the channel. And once again, thanks for watching.